Okay, so if we're going to solve this problem, the first thing we should be doing is drawing a diagram similar to this, and then marking on the masses of the particles A and B. Now A has a mass of 3 kilograms, so I'll write that in here, whilst B has a mass of 5 kilograms, and we'll mark that in there. Now, because B has a heavier mass, it's going to start to accelerate downwards. So I need to mark that acceleration in, so I'll do a double arrow to illustrate that and mark it as A meters per second per second. Now, because the string is inextensible, that means it doesn't stretch, then as soon as B starts to accelerate downwards, A will move upwards with the same acceleration. So I'll mark that in upwards, okay, double arrow again, and call it A meters per second per second. So once I've marked in the accelerations, the next step is to mark in the forces acting on each of the two particles. Now any particle has a weight, and that will act downwards, and it's always equal to its mass times acceleration due to gravity. So the weight on this one will be 3 times the acceleration due to gravity, which is g, so that's 3g newtons. There'll be a tension which will come through from the string here, so that acts upwards, and I'll mark that in as T newtons. They're the only forces now acting on the 3 kilogram mass. When we move over to the 5 kilogram mass, we have its weight, which again acts downwards, mg, in this case 5 times g newtons, and we have the tension in the string which acts upwards, and the tension in the string will be the same tension as the one over here acting on A. That's because the string is passing over a smooth pulley. If it was a rough pulley, these tensions would be different. Okay, so we now have our diagram drawn with the forces and the accelerations. And what we now have to do is consider the motion of each particle. We have to use Newton's second law of motion, which essentially is force equals mass times the acceleration. And so I'm going to look at the motion in an upward direction, and so I'm just going to say that I'm going to consider A, so that the reader will know exactly where I'm doing the calculation, and so I'm going to resolve upwards, which means I'm going to be applying Newton's second law, force equals mass times the acceleration, in the upwards direction, the direction of motion. So for the resultant force upwards, okay, I have T, which acts in the positive sense, so that would be T. And then I have the weight, 3g newtons, which acts in the negative sense, so that would be minus 3g. And this is the resultant force acting on the particle A, and this will be equal to its mass, which is 3, times the acceleration, A. Now because I have two unknowns, T and A, in this equation, I certainly can't solve it at this particular stage, so I'm going to label it number 1. Next, we go over to the second particle, particle B. So again, tell the reader what we're doing by saying that we're going to consider B. Okay. And because B moves downwards, I'm going to look at applying Newton's second law, force equals mass times acceleration, in the downwards direction. So I'm going to resolve in the downwards direction. So the force acting downwards, first of all, is the weight, 5g newtons. So we'll start with that, because that's in the positive sense, so that's 5g. And then the tension, that acts upwards in the negative sense to the motion, so that will be a negative value, minus T. And this now represents the overall force acting on B. And this will equal its mass, which is 5, times the acceleration, A. And we'll call this equation number 2. So I have two equations which I can now solve simultaneously to find out the acceleration and the tension. And the best way of solving these types of equations is to notice that the t's would cancel out if I was to add equation 1 with 2. So I'll say here that what we'll do is equation 1 plus equation 2. And what does this give us? Well, if we add them, as I said, the t added to minus t would cancel, and we would have 5g added to minus 3g, which would give 2g. So we'd have 2g equals 3a added to 5a, that's 8a. And if we rearrange this, we find that we have the acceleration equals 2g over 8, which reduces down to a quarter g, or g over 4, meters per second. And if I wanted to express this as a decimal, taking g to be 9.8 meters per second, if I did a quarter of 9.8, what I find is that I get an acceleration of 2.45 meters per second. Okay, now that I have the acceleration, either expressed in terms of g or as a decimal, I can find t. I can find t by substituting a, say, into equation 1. So if I sub a equals, let's work in terms of g. So we'll say sub a equals a quarter g, okay, g upon 4 into equation number 1. And if I do that, I will have that the tension, T, minus 3g equals 3 times a quarter g, 3 times g over 4, which is going to give 3/4 g. If I add 3g to both sides, I'll then get t, and t will equal 3g plus 3/4 g. And that turns out to be 15/4 g. Okay, and the units would be newtons. So I've got the tension expressed in terms of g. If I wanted to get the decimal version, then taking g to be 9.8, 15/4 times 9.8 gives me a tension of 36.75 newtons.